Okay, level 3 notes. We've just got two examples here. So number 5 says a diagonal walkway through a park is 18 root 2 meters long. If the park is a square, how long is one of the sides of the park? Give an exact answer. That means no decimal. So we want to leave it in terms of a square root. So what we've got here, we've got this park that is a square, and I know in a square I'm going to have all sides that are congruent. And now it says the diagonal through the parkway is 18 root 2 meters long. And it wants me to find out how long one of the sides is. So I'm going to label it X. Well, since it's a square, I know all sides are going to be equal. So now if you see, I've got a right triangle here. And I can use the good old Pythagorean theorem to figure out how long one of the sides are. So I'm going to say x squared plus x squared equals 18 root 2 squared. So x squared plus x squared is going to be 2x squared. And then if I square 18 root 2, that's going to be 324 times 2. Because the square root of 2 squared is just 2. So if I divide both sides by 2 now, those 2's are going to cancel out. I have x squared to equal 324. And now I'm going to take the square root of both sides to find out just what one side is. And x comes out to be 18. So no need to worry about the exact answer because we've got each side is going to be 18 meters, so that the perimeter is going to be that times 4, which is going to be, let's see, whoops, not 3. 18 times 4 is going to be 272 meters. So using the Pythagorean theorem, especially when it's a square, you can label each side as x and just use the process since you're talking about the same variable. Now number 6, an explorer hikes 4 miles east, 7 miles south, 3 miles east, 1 mile north, and finally 2 miles west. How far is he from his original position? So here's where a great time is to draw a picture. I'm going to go ahead and draw the cardinal directions, north, east, south, and west. So I'm going to start down here. If I'm going to hike 4 miles east, I'm going to start out this way. Whoops, you know what? I'm going to start up above since we're heading south. So we're going to start here. And he's going to head 4 miles east and then 7 miles south. And just kind of guide it, guess it, estimate it. Then 3 miles east, 1 mile north, and then finally 2 miles west. So kind of about there. So it says how far is he from his original position. So from his start point to his end point, we want to know how far he is. Well, what I'm going to do is I'm going to make a right triangle and extend that first 4 mile. I'm going to see if I can figure out the lengths of the sides that I just made. So because of that 2 mile west line that I drew, that means the remaining to get back, so he drew, this bottom line here is 3, so that means this is 2 and that's 1. So using this rectangle in here, I know that that's going to be 1 up top. Same thing looking vertically. So we've got this 7 mile south journey, and I've got this 1 mile north journey. That means that to get back to his original spot, this distance here is 6. So now this triangle here, I've got all 2 sides. I've got the legs, so I can find out the hypotenuse. I'm going to label that C. So this length here is going to be 5, and this length is going to be 6. So now what I'm going to do is the Pythagorean theorem. So 5 squared plus 6 squared equals C squared. So 25 plus 36 equals C squared. And that's going to be 61 equals C squared. And if I take the square root of both sides, C will equal 7.81 miles. And that's level 3's. So go ahead and go try the practice and let me know if you've got questions.